A Gedankenexperiment. These are pretty awesome experiments. At least I think so. They're thought experiments. And normally when you think of experiments, say in physics, you're imagining something happening in real life, where someone is conducting an experiment with some instruments, collecting data empirically, and then observing them. But there's another type of doing experiments, and that is just visualizing it and walking through what would happen in your mind using just imagination. Normally, imagination is not the best way to be able to predict the future, and when you run an experiment, you're trying to see what the outcome is based on your initial setup. Imagination cannot always do such a good job in those cases. But let's take one example where a Gedanken experiment can actually do pretty well in being able to get a surprising outcome. Surprising from the point of view of antiquity. There were a lot of ancient philosophers and people of fairly high repute who thought, and they would have philosophical arguments to do so, that heavier objects would fall faster than lighter objects. And an example would be a feather and a rock, and clearly the feather is dropping slower than the rock. Can we use a Gedanken experiment to show that this idea that heavier objects fall faster is just wrong? A lot of high school and middle school classrooms would provide an experiment where they would drop a feather in a vacuum next to a rock or bowling ball or something and show that these two things are falling at the same rate. And that is one way to demonstrate to people who might be skeptical that yes, light and heavy things will fall at the same rate if you get rid of the issue of air resistance. But let's walk through an experiment where we don't have to put any apparatus together, we don't have to build a vacuum or anything like that, and still arise to the same conclusion. So let's take a bowling ball, let's take a marble. Let's ignore the feather for now. Okay, so the idea, if someone is skeptical about things falling at the same rate, they would presume that the heavier object would be falling faster. And how do we show, without a physical experiment, just through a thought experiment, that these are falling at the same rate? Well, we can take these little marbles and we can glue them together. And we glue a bunch of these marbles into the shape of a bowling ball. It's a little bit lumpier than a bowling ball because they're kind of glued together. It looks kind of ugly and messy. But you have something roughly the size and weight of a bowling ball made up of constituent marbles. Maybe instead of gluing the marbles together into a lumpy bowling ball, we just have little thin strings that tie the marbles loosely together. So now you have kind of a more amorphous lump of marbles kind of in a fishnet with each other with strings. And you drop that. Well, we replace the glue with string so they're still tied together. And if you believe that the glued up version of this lumpy bowling ball made up of marbles would fall just as quickly as a normal bowling ball, then this strung up version should be the same as the glued up version. They're all tied together. Okay, well, you can already see where this is going. Why even have these thin, useless strings? They're not really contributing much. So now you just have a collection of loose marbles and you just drop them as a bunch. Final step, instead of the loose bunch of marbles, they're all independent. You can just single out one marble. Why do you need the rest around it? So now you just have the one marble in the bunch that's falling. We basically just walk through a series of changes to this experiment, where finally we're left with one marble that needs to fall the same way as a bunch of marbles, which needs to fall the same way as a strung up bunch of marbles, which needs to fall the same way as a glued up lump of marbles, which needs to fall the same way as a solid bowling ball. So there's one marble and a solid bowling ball would need to fall at the same rate for any of this to make sense. So a thought experiment is great for kind of walking through this scenario. And sure, we've made a few spherical cow assumptions along the way. Air resistance, those sorts of things are considered negligible. And hopefully, even if people were skeptical, and oftentimes in elementary and middle school, the skepticism is real, this Gedankenexperiment might be an alternative way to get them to think through why light and heavy objects fall at the same rate. So this has been a Gedankenexperiment.